Hello and welcome back to my Kubernetes series. In the last two videos we deployed a cert-manager to our cluster as well as a dynamic DNS webhook that will allow us to get a valid certificate through Let's Encrypt. We successfully requested and received a staging certificate and are ready to request a certificate through the production cluster issuer. In this video we will be deploying a certificate replicator. Why would that be necessary? Imagine you have several web service deployments. Let's say one is a website at the root of your domain, but then you have another one, completely different website at the same domain, just under a different path, such as phpMyAdmin to manage a database through a GUI, or you have a forum for your website under a separate deployment in your cluster. As you use the same domain, there is no need to request a new certificate for each deployment. For that purpose, we will be deploying a certificate replication. The certificate will be copied from your master deployment to all other deployments and namespaces where these applications are run. As usual, let's take a quick look at the options we have to accomplish that goal. On the cert-manager website, three options are identified. The first option uses Reflector. As you can see in the description of the solution, you can sync the certificates to the allowed namespaces automatically. The next option is kubectl. It is a similar solution as Reflector, but you need to create a certificate in the origin namespace and indicate where you want the certificate to be replicated to. Last but not least is the kubernetes-replicator. This option allows you to create annotations in the certificate or secret to facilitate the replication into certain namespaces. Once you specified to allow the replication of the secret certificate or config map and the namespace you allow replication to, all you have to do in the destination namespace is to create an empty tls-secret, for example, and the secret will be replicated for you to use in your application. This method is called pull method, but the replicator also supports the push method. I will be deploying the last option, the Kubernetes replicator. So let's head over to the replicator's GitHub and see how we can install it. If we scroll down on the GitHub page, we can see that there is an option to install the software via Helm. As usual, the first step is to add the Helm repository, followed by the Helm repo update command. Once these commands are executed, we can go ahead and download the values file, configure the deployment to our needs, and deploy it in our cluster. Without further ado, let's head over to the terminal and add the repository to Helm. We do that with helm repo add mittwald and paste the address. Once done, we enter helm repo update and the repo is updated. Next step is to helm search repo mittwald. As we can see, there are quite a few charts in here, but we are interested in the Kubernetes replicator. As we found the chart we are looking for, let's enter into our setup folder and we will go into the cert-manager folder. In here we want to add mkdir03 replicator, and we want to download the values file with helm show values from the repo mittwald /kubernetes-replicator, and we will output that into the replicator-values.yaml. Now that it's downloaded, we can start editing the values to and adjust them to our needs with vim replicator values. As we have quite some values to customize, let's start at the top of the file and work our way down. We will start with the args or arguments. I want to activate the resync period, which will resynchronize our objects every 30 minutes. However, it's not sufficient to remove the two characters, the hashtag and the space after it. You also must remove the brackets, as otherwise you will be greeted during the installation with error messages, so please remove the brackets and only then move on. The next part is the service account. That part was a little bit annoying to figure out. I wanted to provide a service account name through this file. If I, however, specify any other name than kubernetes-replicator, the app will not run. The reason is that the deployment and the creation of the cluster role and cluster role binding requires this name. So we will not touch this value and move on to privileges. That piece was a little bit challenging to figure out as well. I want to activate the privileges, so I will remove the brackets. However, right after privileges, we see an entry called auto mount service token. That is not a privilege. The privileges are one row below. So the API groups and the resources, those are the privileges that should follow line 25. As they don't, we have to add a line under privileges and then paste those two privileges right underneath. Only then we can remove the hashtag and the space after it, as well as one row below. As I also want to synchronize secrets, I have to add in quotes secrets right after the config maps, and keep in mind to separate those values with a comma. Then we can delete the empty row under resources, and we can also remove the duplicated API groups and resources from this file. Next, I want to activate the security context. So we remove the curly brackets, and then we can move on to remove the hashtag and one space character right in each row underneath. Once that is done, I have executed all the changes I want to make to this file, and we can write and quit. As we customize the values file, let's now deploy the Kubernetes replicator in our cluster. I will deploy it in the cert-manager namespace. You can easily deploy this application into its own namespace, but I will keep it all together here in the certificate or cert-manager namespace. To do that, we do helm install kubernetes-replicator. Please keep in mind this name will also be used to create the service account, and it has to be Kubernetes replicator, as otherwise this deployment will not run. So please make sure to call it Kubernetes replicator from the mittwald repo Kubernetes replicator into the namespace cert-manager with a values file replicator-values.yaml. And we deployed this application, and we'll wait for it to start up. And our application is all up and running. Now that we deployed the replicator, we want to go ahead and test that application. To do that, we need two things: a source and a destination. So let's go ahead and find a secret that we can replicate into another namespace. We should still have a kubectl secret in the namespace test web. And there it is. Fantastic. But we have no namespace to replicate the secret to. So we will go ahead and create a namespace, kubectl create namespace, and we're going to be very creative and call this test namespace. Kubectl get namespace. Guess we can also stop the watch on the right hand side. At least for the cert-manager, we have our test namespace. Now we have to do two things. Number one, we have to change or add to the source secret. So we are going to start with that step by saying kubectl edit secret, and it's called tls-secret in the namespace test web. Alright, the data. Alright, we are down at the annotations, and that's what we want to add. We want to add an annotation that allows this secret to be replicated. To mark this secret as a secret that can be replicated, all we have to do is add the annotation replicator.mittwald.de/replication allowed, and we set this field to true. The next line we have to add is what namespace do we allow to pull this secret in. For that, there is a second annotation, which is replicator.v1.mittwald.de/replication allowed namespaces. And these namespaces that we define here, only those namespaces can pull this secret in. So if we define, for example, our new namespace that we just created, the test namespace, that namespace can come over here, figuratively, and say, hey, I would like that secret to be replicated. And the secret checks, hey, where do you come from? I come from test namespace. Sure, you can have it. That's basically how this replication works. The secret is edited. That was the first step. So now we have a secret that is allowed to be replicated. The next step we have to do, we have to create an empty TLS secret for our test namespace. To do that, we enter vim secret-replica.yaml. I'm going to copy and paste a template in here. We're going to call this tls-secret-replica. That's fine. We have test namespace. That's good. Annotation, and that's what's important for this piece here as well. We say annotation, replication v1 mittwald.de replicate from test web, and the TLS secret is what we want to replicate. Once that's done, we can write and quit this file, and it's ready for its deployment. Before we now deploy that secret in our test namespace, let us start a watch for the not all but secret. We want to see what happens when we deploy the empty one, and we want to see, is there a change happening once we deploy, well, if the secret is pulled or not. So let's watch for the secret in the test namespace, which is going to be empty now. That's okay. And now we want to deploy kubectl apply-f the secret-replica.yaml. Okay, which is fine. Of course, the secret will be empty as we've deployed an empty TLS key and the certificate. Now, let us describe this secret and see if it is filled with the values we wanted to pull from the test web namespace, or test web namespace. Yes, that's correct. kubectl describe secret tls-secret-replica-n test namespace. And I would call this a success. First of all, we see all the information in here. And we also see additional information from the replicator, that it replicated from a version 157 and so on. And we can see that there is a TLS cert and the TLS key that was replicated. If you remember, let me bring this up on the bottom here, cat secret replica. Our TLS key and TLS certificate were both empty. However, we now have values in here, or rather sizes in here. That means those two keys, or the certificate and the key, are not empty anymore. If you want, you can also compare it to the origin secret, which we can see through kubectl get secret TLS. We need to describe the secret. Sorry, describe secret TLS secret -n test web. And as you can see here, the sizes absolutely correspond, which means we have successfully replicated our secret. With that, what's working? We have a cluster, we have the certificate manager, a webhook, and now with the latest application that we deployed, we can replicate secrets and certificates to make sure we don't have to request them several times for the same domain, and can use them in other deployments. What's next? Then in the next video, I will walk through a quick deployment when it comes to synchronizing your ISP assigned IP address to your dynamic DNS service provider. Once that's done, you can be sure that your services are always available from the outside of your cluster, and you can access these services from wherever you want. Until then, thank you so much for watching, and I'll see you in the next video.